Welcome back to lesson 8, where we are going to apply rules for doing the derivative. And the rules for doing the derivative is the power rule. The power rule says that the derivative respect to the x of x to the power n, let's say 4, 5, 6, or 1/2, is n times x n minus 1. And also it says that if you find this equation a x to the n, the derivative of this function, you can take the a out. A can be 3, 4, 5, or pi. So it will be a by the derivative respect to the x or x to the n. And now it will be, the derivative will be a n x n minus 1. So this is what we have to know to do all these problems, and to note also that the derivative respect to the x of f of x, the derivative respect to the x of f of x plus g of x is equal to the first derivative plus the second derivative. This is true when the sum of two functions, when it's a product, it's not true. So what it says, this expression is, you have two functions, let's say these two. You stop at the point x. You see what is the slope at this point. Let's say this one. Let's say 3. And you see the slope at the same point of the other function, the g. And let's say that is 2. The slope of the function x of the function of the new function f of x plus g of x, the slope is the sum of the two slopes. This is what it says. Okay. For example, if f of x, let's go to do it here, if f of x is 3x, what is the slope? 3. If g of x is 4x, what is the slope? 4. What is the function h of x? That is the sum of the two. So it will be 3x plus 4x. What is the slope of this function at any point x? Well, the slope of this function, 3x plus 4x, is the same as 7x. What is the slope of 7x? 7. So the equation that takes place is that in these two rectilinear lines, for others is also valid, no? That the slope of the sum of a function that is the sum of two is the slope of the first plus the slope of the second. Okay, let's go to do problem 1. We start. Find the derivative. So how we will do? You write the fifth root of x like x 1/5, and you apply the power rule. When you apply the power rule, you will find 1/5 x 1/5 minus 1. Minus 5 divided by 5, you can reduce to this expression. And the problem is done. Let's go to the second one. Find the derivative. So the power rule again. What is the derivative of t cubed? 3t squared. What is the derivative of 5t squared? 2 by 5 is 10. 10. 2 minus 1 is 1. 10t. What is the derivative of 3t? 3. What is the derivative of 8? The derivative, the slope of the function 8 that is constant is 0. So plus 0. So we have applied the facts that when you have the sum of many functions, the derivative is the sum of the slopes. Okay. 3, find the derivative, same thing. You can do it, apply the power rule, and you will find this result. Next problem, find this derivative. Oh, this one you have to be a little bit careful, and you write the square root of x like divided by x, and so the x is square root of x multiplied by square root of x. So one will cancel with the other, so it will be the derivative of x of 1 divided by square root of x. The other thing that you can do is to write this like x1/2 divided by x1. And this is x1/2 minus 1, which is x equal exponent minus 1/2. So this is 1 divided by x1/2, and this is the same that I have here. Okay, the same that I have here. And now I apply the power rule. If I apply the power rule, it will be minus 1/2 minus 1/2 x to the power minus 1/2 minus 1, which is minus 3/2, and the problem is already solved. So you can write it in nice form, and that's all. Let's go to the next problem, sine 1. We found the derivative of this of the first function first. Later on, we find the derivative of the second function. Now, we need to know this thing. The derivative respect to the x of sine of x is cosine of x. And the derivative respect to the x of cosine of x is minus sine of x. We will do the formal proof that this is true in class. From now, we accept that the slope of sine of x. So imagine that, see how beautiful is this thing. Sine of x is a function that does like this. Imagine that I stop at this point, pi divided by 2. Sine of pi divided by 2 is 1. The slope here is 0. What it say that if you want to find the slope of sine of x at any point x, you go to the function cosine of x. The function cosine of x is 1 when x equals 0, is 0 when is pi divided by 2, and the function cosine of x does like this. Okay, so what is the value of cosine of x at x equal pi divided by 2? The value of cosine of x at x equal pi divided by 2 is 0. And the slope of sine of x is 0. So in this function, in the function cosine of x, gather the information of the slope of sine of x at any point x. You can check it. You can find, for example, this point. What is the slope of this point? It looks minus 1. So you go here to the same point, you go to the information of cosine of x, and the value of cosine of x is minus 1 at this point. And this point is the point pi, and pi. Okay, let's go to the next problem. Okay, let's go to do this problem. It's a problem 6. It's a given the equation 3x cubed minus 10, find the equation of the tangent line at the point 2, 14. So 2, 14 is a point that belongs to this function, because if I input the point 2, 2 cubed will be 2 by 2 by 2, will be 8, 8 by 3, 24, 24 minus 10 will be 14, so this point indeed is a point that belongs to the curve. So what it says, find the slope. To find the tangent line, we need the slope at the point. We need the slope at the point x equal 2. So we find the derivative. The derivative of 3x cubed is 9x squared. The derivative of 10 is 0. So the slope evaluated at x equal 2 is 36. So the equation of the tangent line, it will be y equal y1 plus m multiplied by x minus x1. y1 is 14, is this point. x1 is 2, is the point 2, and the slope is 36. So the equation of the tangent line is 36x minus 58. So you can go to a graphing utility like GeoGebra and check that this graph, you graph first of all this function, and later on you ask him to graph this function, and you see that this function kiss the point 2.14 tangential, he gets once the point. Okay, let's go to the is similar, is just instead of x appear the variable theta. So how to do the derivative? So you imagine that when you see the theta is the x. So the derivative respect to theta or respect to x of 4 sine of theta or 4 sine of x minus theta minus x is the derivative of sine is cosine of theta. 4 is 4. And the derivative of x is 1 because the slope of the function y equal x is 1. So the derivative respect to the theta is 1. We evaluate this at theta equal 0 because we need the slope at the point theta equals 0. If we evaluate cosine of 0 is 1, 4 by 1 is 4, 4 minus 1 is 3. So the slope at the point theta equals 0 is 3. To find the equation of the tangent line, again the same thing, y equal y0 plus m multiplied by x minus x0. But instead of the x, we need to plug in theta minus theta 0, and instead of y of x is f of theta, or y of theta, or y of theta 0. You plug in the numbers, and you will find that the tangent line to the point theta equals 0 is f of theta equals 3 theta. Okay. And now let's next problem, that is problem 8, is it's a find the equation of tangent line to the use graphing utility. Okay, you do the same thing. So I will leave you to do it. It's done here, okay? If I didn't do any mistake, this is the tangent line. You can graph this tangent line and see if it is with GeoGebra. You graph the function and you graph the tangent line and you see if it is the point 1.6 tangentially. Okay, next one. This problem is interesting. It say find the slope, find at which points of this graph of this function the slope is 0. Of course, you can go to GeoGebra and you can graph this function and you can see for which x the slope is horizontal. Well, let's go to do it mathematically speaking. So the slope of this function is, you know, the power rule, is 4x cubed minus 2x minus 4x plus 0. So the slope is this. And this slope we want to be 0, and we want to find which value x have to be in order for 4x cubed minus 4x to be 0. So we can factor 4 times x cubed minus x. We can factor again x, and x multiplied by x squared minus 1 will be x cubed minus x. And now we can factor x squared minus 1, and we can put it like x multiplied by x minus 1 multiplied by x plus 1 equals 0. And now we are asking ourselves, when this is 0? This is 0 if I plug in x equals 0, because 0 by something is 0. So for x equals 0 is a solution. So at x equals 0, the slope is 0. What other points are that the slope is 0? At x equals 1, 1 minus 1 is 0. 0 by something is 0. And x equals minus 1 is another point where the slope is 0. So as a result, this function has 3 points where the slope is 0. And slope 0 means that the curve achieves a maximum or a minimum, a relative maximum or a relative minimum. So the function, the points are the crucial point or the critical point at the point 0, 1, and minus 1. When x equals 0, the function takes the value 3, because 0 minus 2 times 0 plus 3 is 3. At x equals 1, the function takes the value 2. At x equals minus 1, the function takes the value 2 also. So the question is, with this information, can we try to graph the function without using GeoGebra? Yes, we know that at this point the slope is 0. We know that at this point is the point minus 1, 2. This point is the point 0, 3. And this point is the point 1, 2. Okay, can we graph the function? Yes, we can graph the function. The function should do like this. It has a minimum here where the slope is 0, so the tangent line is horizontal. It has a maximum where the slope is 0, it has again a minimum where the slope at this point are 0. So this is the graph of this function without using GeoGebra. Okay, so what we have learned in this problem is that when you find the derivative, the slope, and the slope is 0, it means that there is an horizontal line like this one, horizontal. And this horizontal line means that at this point, at x equal minus 1, at 0 and 1, there is either a maximum, a relative maximum, or a relative minimum. This is what we have learned in this problem. And, well, on this problem, we will do as applications of calculus, these kind of problems. Weight, annual earnings, we will use the derivative to find the rate of change. And we will do all these problems when we master these ideas. Okay.